All right, welcome back. This should be our last video where we're going to solve for the remaining 5 internal forces of this truss. In the last video, we found these two forces right here. CE is a compression force, and we've got DE here is a tension force. So moving forward, we've already looked at joint E down here, okay? That's how we found these first two forces. Now we need to look at our truss puzzle here. Remember, think of it like a Sudoku and figure out, okay, well, where do we want to move next? Well, where do I have some numbers that I already know? I've got numbers here and here, so it would probably make sense to take a look at joint D. So I'll go ahead and snag that. Oh, that was bad. Let's grab this. Boom. Copy. Paste. There we go. All right, now here's what's really nice about this one, okay? I've got right angles everywhere. That means I have no trig that I have to do, and I really want you guys to get in a good habit of just not making this process more difficult on yourself, right? I know that all my X and Y forces have to equal, right? If I sum up all my X forces, it's got to equal 0. So if I have 600 newtons going this way, I have to have 600 newtons going that way, right? And I've only got one X force that I haven't solved for. So if I've got 600 newtons right here, I have to have 600 newtons right here. And that one also has to be in tension because that arrow has to pull this way to the left. All right? So look how easy that is. AD I've already solved for. 600 newtons. It's going to be positive because I can tell that it's in tension. You see what I did there? I mean, you don't have to always do the math. I mean, sometimes you do, but if you can save yourself some time, save yourself some time. It's nice. Same deal here. I got 1,000 going down. Well, I have to have 1,000 counteracting that, pulling up, right? If it's pulling up, pulling away from the joint, that means it's going to be in tension, and that number is going to be positive. So let's go ahead and keep these red so they stand out a little bit. 600 newtons, 1,000 newtons. Okay. Let's go ahead and put in a 1,000 right there. See how this stuff starts to come together kind of more quickly as you go through it? It's kind of nice. All right, I've got a few left that I need to do. Where do we want to move now? I think we might now have enough where we can look at joint A. Let's take a look at joint A. Joint A's got a lot of forces, but I think we can solve for at least some of them. Copy. There we go. All right. Static equilibrium. Okay. Do we want to start with X or do we want to start with Y? Sorry, you can probably hear my dog barking in the background. Well, it doesn't really help us to start with Y because this is an unknown Y and AC also has an unknown Y, so we probably can't solve for anything. But how about the X forces? If we think about the X forces, that's an X force, that's an X force, but we don't have any X force. So we don't know the X portion of AC, right? We don't know what that is. So that's something we could solve for. All right, and that'll help us solve for AC. So we're going to do trigonometry again. Okay. Sorry, we need to solve for this angle. Call it theta A. All right, so we're going to have some triangle here. It's theta A. This is AC. No, sorry, that's not AC. But we know what these distances are. 12 on the bottom and 12 on the side. Oh, that makes it easy. So if this is 12 and 12, well, I could do trig here, but really I know that if I have the same side length on both sides, then that has to be a 45-degree angle. Okay, if you punch this into your calculator, this tan inverse, you'll get 45 degrees. Okay, so you can do that as well. but I know it's 45 degrees, so that's kind of helpful. All right, so I can come in here and know that this is 45 degrees. All right, so what do we got going on then? We have some of our X forces. That's going to be minus 500 newtons. Okay, that's right there, pulling to the left, plus 600 newtons. Okay, that's there pulling to the right, and plus ACX equals 0. Now, if we think about, we got AC, ACX, ACY, it's 45 degrees, okay? ACX is going to equal AC times the cosine of 45, okay? You need to be comfortable doing this kind of quick calculation, all right? If you are confused by that, go back and watch the second video where we solved for CE, okay? That's when I did that a little bit slower, but we know that it's going to be AC cosine 45, okay? Cosine being adjacent over hypotenuse. So, all right, let's just kind of simplify this out a little bit. Let's see, minus 500 newtons, let's say plus 600 plus AC cosine 45 equals 0. If I simplify, I'm going to get AC cosine 45 equals minus 100. Okay, so AC is going to equal negative 100 divided by the cosine 45. And if I do that on my calculator, okay, 100 negative divided by 45 cosine close parentheses equals negative 141 newtons. So if I'm negative, that means I'm in compression, meaning this arrow needs to come back in, okay? And that is 141 newtons of compression. So we can go fill in that information on our chart here. Nope, sorry. We'll do this for AC. Compression, and that's going to be negative 141 newtons. Okay, solve that one. Now all we need to find is AB, our last one. So let's go ahead and I need to clean this up a little bit. Let's see, that's going to be 141 newtons, and that's an angle right there. Let's just take this again and copy that. Oops. Copy, put it on this new page. You can see this takes up a lot of room. All right, and let's do the Y forces. So I've got 100 newtons pushing up right here. I've got AB and I've got ACY, and that's got to all equal 0. Well, what can I do? I got 100 newtons plus AB, okay? ACY has to equal AC sine 45. Again, remember I did this math right here. To find this for my ACX, that means my ACY has to equal AC sine 45. Again, if you're not comfortable with that math, go back, watch the video where we solve for CE. Okay, that's where it comes from. Okay, so I'll plug in some numbers. 100 plus AB minus 141 sine 45 equals 0. So we're going to get AB is equal to 141 sine 45 minus 100. And let's see what we get there. Let's see, 45. Oh, not sine inverse. Oops. Clear out. 45 sine, okay, times 141 minus 100. And we're going to get, wait a second. Ah, look what we got there. With the rounding, it becomes a little confusing, but what we actually get here is 0 newtons. Okay, I know that this looks like it's minus 0.3. I promise you, if you go back, I don't know, if you do the math without rounding, you'll get right at 0 newtons. Okay, so you'll have to trust me on that one. But this is 0 newtons. Look at that. No force at all in our AB. Okay, 0 newtons for AB. And AC was negative 141 newtons. Okay, so there's no force here. Okay, interesting. All right, we have one thing left to solve for, and it's BC. So let's take a look at joint B. This ought to be easy. Okay. Some of you might notice, hey, wait a second. There's no force there, and you would be right. Look what we got, okay? Remember, static equilibrium, okay? Sum of all x forces equals 0, sum of all y forces equals 0. All right, well, do I have any y forces? No, I do not. Because the only thing I have is 0 newtons. So that's nothing. Okay, good, my y forces are good. What about my x forces? Well, the only x force I have is BC. So BC plus nothing has to equal 0. So BC is also equal to 0 newtons. Look at that. There's absolutely, there's Ellie. There's absolutely no force in these two members. Nothing. You might as well get rid of them. Okay, they're not doing anything to strengthen your truss. In fact, you literally could get rid of them, because even if you got rid of them, you'd still be statically determinate. So yeah, they're not doing anything. Okay, kind of interesting. Now, if we had, some sort of load applied here, that would make a difference, but we don't. So we're done. Here's our answer. Okay, there's all of our forces. So think about what this means. If we start applying the loads that are present, right, if we go back to our initial scenario, right, we apply these, apply these loads here. Sorry, it was those two. Everything else is a reaction force. Where is most of that force being channeled? Well, it's being channeled to mainly members CE and CD. Those are bearing 1,000 newtons or even more. Okay, so something to consider. Could we make this shape better so that the force is more evenly spread out? We've got members up here that aren't doing anything. Anyways, this has been a long series of videos. I hope that they were helpful, and I look forward to seeing you tomorrow in class. Thanks.